Okay, this is being recorded, right? So for that, for basically visualization, we need to do so. Basically, let us first take some data set. Do this. Okay, let me put in some data here. Last time we saw the restaurant.csv, you know. Okay, let's put that there. Put pandas as pd. So first we'll start seeing visualization using pandas only. Okay, like that's the simplest visualizations, and then we will cover Matplotlib and Seaborn. Those are a bit advanced, and this is very important because whatever analysis we have done, usually when we need to show that, okay, we don't show it in tabular format. The best way is to use a graph or a chart, and then only we show these things. Okay, let's say the simplest analysis that we can do is, let's say you can suggest we want to find, let's say city wise, what is the average rating. So how will we do that? City wise average rating. So you have DF and you do a group by city and mean. Fine. So like this you will, oh, mean of what? So if I don't select, then it would not exist. The city is capital and mean of rating. Fine. Now you see this you have got. Fine. Let's say we name it as city mean. Okay. And this is what city mean is what. If I do a type of this, what would we see? Sorry. Type would be what? Pandas series. Okay. Because this is a single row and a single column only you have, and one is the index column. So index column and single column, that comes a panda series. If there are more than one columns, then it becomes a data frame. So you could also do dot plot. Let's say if I just do dot plot, okay, what would happen? You see, I'm just using the default dot plot. So this comes with panda. So on any panda series, you can do a dot plot. Use the dot plot function. Now you see this is what this is known as a line plot. Okay, on x-axis you can see the different cities, and on y-axis you see the average rating. Okay, but there are many kinds of plot. The ideal plot in this scenario would be a bar plot. So I'll show you what is a bar plot. See, this makes more sense. Line plot was not that legible, and this makes more sense. You see, this shows me all the cities and the chorus. The higher the value of the bar or the height of the bar, it means better is the rating. Okay, mean of rating. Okay, so this is bar plot. Okay, this is most commonly used plot in these scenarios. Okay, now let's say instead of this, we want to use, let's say, Delhi city rating, and what else can we use? Let's say we use different. Now we need multiple. If we need multiple columns, so I'll show you multiple. We also want to see the mean value of rating and the, let's say, mean value of cost. Okay, or not. Cost and mean value of rating won't be compared because this is very low and this is very high. So let's say now we want to see the mean value of votes and the mean value of cost. Okay, let's try that. So votes cost mean is equal to df group by, and you group by city, and you now, because you need what, you also need rating, not rating, sorry, you need votes and you need cost, so you need to select both. And when selecting more than one column, I told you we use these double square brackets, okay, and then you find the mean, so it would give you mean value of both these columns city wise. If you see this, see, this is, now this is what a Pandas series or a data frame. Very good. This is now a, if you see the type, core data frame, fine, because there are more than one columns. Now if I want, and this is the row index, the city name, you know. Now if I do a dot plot, if I just simply do a dot plot, then what would happen? Let's see. See, by default it takes a line plot. Okay, so I need to provide kind is equal to bar. So bar plot. Now see what it would do. Now you see. You also have votes in blue, and you also have the cost in orange. Okay. If instead of, this votes and cost, if we would have compared rating on the same graph, then what would have happened is that rating value is very low. It would be around 4 point something. So it won't even show. I'll show you why we are not taking rating. Because when doing, plots and all those things, it's very important to understand what to do, what all columns to include in which plot. You see, rating is there in this in green, but so the value is very less. That's why we usually avoid, we use comparable measures. Okay, this makes sense. Okay, very well. We could have also done like this. Now let me show you one more thing. Votes. What's the name? Vote cost dot plot kind is equal to bar and tagged is equal to true. Now see, stacked means that you stack the columns one over the other. So blue, on top of blue there is orange, on top of orange there is green. So this is known as stacked bar plot. This is normal bar plot. This is stacked bar plot. Now let's say these, as you see, these bars are what? These bars are vertical. If instead of vertical you wanted horizontal bars, so you could simply done this bar H. H stands for horizontal. So see, now all the bars have become horizontal. Very good. Okay, so this is known as, bar plots is usually a bivariate analysis tool. Okay, by bivariate I mean there are more than one variable. See, there is city and there is rating. Here there is city and there is votes, cost, rating. So bivariate or multivariate. Okay. Simple bar plot is bivariate. If you use more than one columns, there are multiple bar plots, or there are stacked bar plots, then this becomes bivariate or multivariate. Okay. So this is what these are. Let me put it here. Bar bar plot, bi and multivariate. Okay. So this is one kind of plot. Now let's see histograms. You know about histogram? No worries. These are univariate. Okay, these are usually used for checking the distribution of, variables. Let me show you. Let's say you have df and you select your votes and you just do a plot kind is equal to hist. See, So this shows that between 0 to 500 there are maximum values of votes. Okay. If I would have done ratings, this would even make more sense to you. That if I take rating, so you see, maximum ratings are between 4.25 to 4.5. You know? Then minimum rating is between this 1.5 to 1.75. So this means now you see we are just using a single column. So this is single variable. So this is known as univariate. And these are histograms. Okay. So we can also do it on, let's see, let's do df rating. We do df votes and df cost. Now you will see, you see, there is an overlap as of now. Okay, so what you can do, because there is an overlap, so you see you cannot see the ones that are behind. So the votes is not visible exactly how many votes were there, how many values between this and this were there of votes. So you can use this parameter alpha is equal to 0.5. 0.5. Alpha means add some transparency. Okay, see now these have become lighter and there is some transparency. If I put it alpha is equal to 0.9, then this would be less transparent. So you see the transparency is less. If I put this 0.1, it would be very transparent. See, so usually we take it around 5 or 7. Okay, so that if there is any overlap, because we are seeing histograms. Okay, so multiple, columns can also, so we can see the distribution of cost. You see, cost, although maximum value of cost is between 0 to 500 or 750 something, but still you see there are many between 1000 to 1500 also, but for votes there are not many between 1000 to 1500. Okay, so this is how we see the distributions of various columns. Now this you could have also done if you don't wanted alpha. There is one more way you could have also done stacked is equal to true. See, so now this has become stacked. So the one which is having lower value that would automatically come ahead. Ahead. Hmm. So you see blue has come ahead. And over blue they have the rest of oranges coming. So this means stacked. Fine. Very good. So this is tagged bar plots. Now there is one more thing. You see how many bins are there? Bins means bins. This one, single bar is known as because these are bar plots. So this is a single bar, and bins means so from 0 to 1000 or from 0 to around 800. You see there is one bin. This is another bin. This is another bin. So bin means that how many. Let me draw it here. Okay, this range on which this plot is being drawn, every bar is being drawn. So this, you know, this is known as a bin. This from here. So this thing entire, this is known as one bin. This is another bin. This is another bin. Okay. These are known as bins. So currently you have around, let's say from 0 to 8000, around 8 to 9 bins. You know. So if I change, let's say if I use let's use a single variable only, and let's use rating only. So currently you see without any bins, it automatically decides based on the value. Okay, so there are these many bins. So let's say if I want to make just 5 bins. So now you see what would happen. Rectangle coordinates, bins, bins. Now you see. One, two, three, four, five. See, this is one bin from here till here. This is another bin. This is another bin. So what? This is one, two, three, four, and five. You know, five bins. So this you can change based on how you want to see your distribution. Okay. Like in this scenario, you see, there can be many bins also. You can also make it, let's say, 50. So then what would happen? See, you see, these are very small bins. When you want to see more granular information, okay, so the bin size is now very less. So you divide 5 by 50. So 5 by 50 is 0.1. You know? So 0.1 is the bin size. So from 1 to 1.1, from 1.1 to 1.2, 1.2 to 1.3, 1.3 to 1.4, 1.4 to 1.5. So you can see exactly more granular information. Between 3.5 and 3.6, there are these many. Now we were able to see earlier, let's say we were able to see earlier that the maximum, you know, rating is between 4.25 to 4.5, something like that. You know, now you can see more granular. The maximum rating is between 4.4, 4.3 to 4.4. You know, this is how we understand information more granularly. Fine. Okay. So this is how we can do binning, and this is how we, these are known as univariate histograms. Okay. Now let's see, there is another box plot. Let's see what is box plot. Let's take this only. Let's take our rating only, and the kind is equal to box. See, are you able to see this? Okay. Visualize. Right. So in this box plot, what happens? You know, this this tells you many information. Okay. So this is your mean value. Okay. This is your mean value, or you can say this is where your maximum data is. Okay. So we saw that around 4.3 we were having maximum data. You know, your mean value. So this is highlighted like this. And this is where the maximum, this box shows that this is where the maximum data lies. Okay, between this and this. Fine. And then this range tells you that this is known as the interquartile range. Okay. So basically, this shows that data is there between this and this data. That is not an outlier. So outlier means something that is very far away from the mean. Okay. Now I'll explain you this. Let me show you. I'll show you. Where is it? Okay. So now you see. If we see the plot of, let's start with df, and let's see votes, and let's see plot is equal to kind is equal to bar. Okay. Let's see this part. Not, we don't need bar. We actually need a hist. Stop this. Hmm, this is not stopping only. The bar plot requires two variables. Here we need a histogram. Interrupt. Okay. Now this is, I have to run again because I've interrupted it. Okay. This is fine. Now let's run this. Okay. Now you see. Now this bar plot tells that there is data here. Okay, maximum data is here. Then there is data here, here, here. But there might be very less data if you see the maximum value of votes. Votes.max. So then you see it is around 5,000. Okay, but this is an outlier. Okay, why outlier? Because it is very far away from the mean value. So if you see the mean value, I'll show you mean value of votes. See, mean value is around 119 and maximum value is 5,000. So what would happen if you train, let's say tomorrow, any machine learning model, or if you are even doing some data analytics, है ना? So what happens that these are, a restaurant having these many votes, that would be an outlier. Why? Because that would be, this votes would be largely influenced by this value. Okay, so usually the value is, let's say, between 0 to 1,000. Okay, we are for most of the restaurants, but for this restaurant, because the vote value is this much, so it would be difficult for the model to understand, you know 5,000 means what, 4,000 means what, 3,000 means what. But if we limit the model from, let's say, 0 to 2,000, then it would be easy for any model or any person also, you know to make sense more from the data. So now you can just do a box plot, and box plot does what? This helps us identify such kind of outliers or such kind of uh, values that are deviating from the mean. Okay, so you see, this is that value. Now your mean is around this, 119, and all this data that you see in dots. Okay, these dots, these means, these are very far away from the mean. Okay, so just for seeing if there are too many, data points that are far away from the mean. So there are certain standard deviations that we check. So let's say one standard deviation, 1.2 standard deviations away from the mean. So that is considered as an outlier. Okay, and when we will see machine learning, okay, when we will see machine learning, then we would also see why outliers have to be, pre-processed, and we have to deal with them. Otherwise, our machine learning model would not be able to make correct sense of the data. Fine, because this is very rare. Only one restaurant is having this value. This is very rare thing that is happening. So because of this, because in machine learning, our aim is to generalize things. Our aim is to generalize things. But in this cases, you see, there are specific values, and these are very far away, very rare combinations. So that's why we use box plot to identify such things. Fine, very good. So these are known as box plots, and there can be, multiple box plots also. Let's say you are doing it for votes, you can also do it for, let's say, rating, and you can also do it for, let's say, cost. So you see, all these would be, there would be a box plot. But the issue is again with that rating, the value is very small as compared to these two. So usually we don't combine these. We do it like this. So you see, so cost also has, so for one restaurant, the cost was 8,000. There is a box, but that's very small. You see, what I can do is I can show you df votes. Okay, let's take df only those value of data frame where votes are less than 200. Okay, then let's plot. Then you will be able to see the box. Uh, okay, let's just take votes from here. You see, fine, makes sense. Okay, this is fine. Okay, So here we see what is the. So one thing here in this green line, this is actually the median value. Okay, this is not the mean value. Okay, because mean is around 100 something, 119. This is the median value. If we see df votes dot or let me check if what is the mean for just less than 200. I have to confirm that. Let's see what's the mean coming for all the values which are less than 200. It's around 40. Okay, but here you see, let's do a median. You see, this is median value, the green line. No, mean is not necessarily last of box. So this is like the interquartile range that we see, that is there. So this means that there is around 1.5% data here. So that interquartile range I can explain that to you. So that would need some formula. So let's say our mean is 25 or 19. Okay. So one second. Let me take 19 is our median. Okay, and the entire data is this much. Let's say just less than this only. Okay, so now for calculating this, what we do, think everything that is above this value, we take that. So we all can also do, there are quartiles. Are you aware of quartile? Huh? Are you aware of quartile? No worries. I'll show you. First, we need to calculate the quartile. What does quartile means? So let me show you. Let's say df votes dot quantile 0.25. So this means that 25 around 25% data of df votes lies at like below this value. Yeah. Okay. So if you see how this was calculated, let me show you. Total length of df votes is what? Yes. How much? Okay. Now, if we just take less than equal to 6, and what is how many records are there that are less than 6? See, 1682 divided 6593. So see, around 25%. Around 25% data of this lies below 6. Now similarly, you can also do df votes quantile 0.5, 0.75, and 1 to would simply mean the maximum value. All data is behind that. So you see, 50% data is less than 31, 75% data is less than 115. Okay, this is how we calculate quantile. In these exams, we usually get this quantile kind of results also. That this much is your, quantile. Instead of your percentage, like in I think in CAT exam and all those things, they give you quantile. Okay, so it means you are ahead of this many students. Okay, if you have let's say 115 marks, then actually your quantile is 75%. So you are ahead of 75% of the students. This is what it means. Okay. Now IQR means the 31 we are having and 6. So I think IQR is actually 115 plus 51. Where is it? Sorry. Think it is for calculating exactly the quantile. I don't remember IQR formula. Let me check that. Just no, not just a second. I'll tell you. The formula should be. Hmm. So for all the data, let's say that is between. mm, Uh, this is Q1, so this should be between the upper portion. So that is above 115. That is above 31. Okay, and that is so 31 means what? 50% quantile, है ना? 50% quantile. So 50% data is below 31, and all the data that is less than 75%, 115. Okay, let's take that data. So this is that data that is between 50% and 75%, and take the votes value and calculate the median of not that. Let's first check what is that. It's around 59. Yeah, so this is what is this box value, 59. Sorry, this is what? This is the upper uh, upper interquartile quartile range. Okay, this means yeah, Q3 minus Q2 median. Okay, all the data between Q2 and Q3 and median of that. Okay, similarly, if you want to calculate the lower part, this box ka this part, starting part, so you take all the data above 6 and all the data below 31 and find the median of that. This is Q1, Q2. This should be around, this should be around, okay, so they are taking this as 6 only. This is 6 only, the starting of the box. Just a second, let me see median of the lower portion. Hmm, 50% is 31, and if this would only be our median. So 50% data is actually our median only. I think this we are doing it for, the issue is that we are doing it for less than 200, na? So that's why it's coming less. So the formula is this only. So this should be 15 only. Because we are taking all the data that is already less than 200. So means we'll have to do it like this. Then the exact values would come. And again this. Hmm. Now we'll have to update this also. So now you see one has become what? 199 because it was less than 200. Yes? Now no value is above 200 or equal to 200. Make sense? No worries. See, first we are filtering for all the data that is for having votes less than 200. Okay. So 199 is the maximum value. है ना? So quantile of 1 means what? 199. So everything is below 199. Because then we were not doing this filtering. Na? We were taking all the votes starting from 0 to 5,000. We are taking entire data of votes. So there are six, votes is starting from 0 and votes is ending till 5,000. But we have here restricted the votes till 200. So no more than 200. So out of this, then we calculate the quantile value. So then we get 6, 30, 150. This would now change. Now we get 5, 19, 59, and 199. Okay, now you see the interquartile range is calculated like this. This should be greater than 19, that is the median, and less than 59. This should be greater than 5 and less than 19. Now you see 34 and 10. Now if you will see, this will be this, oh, this should be 190, 59, 59, 19. Greater than 19 and it is less than this much. This is coming as 59. This is coming as 5. This is coming as 19. Okay, I think this is the not required. All this is not required. Yeah, this is just this much. Fine. Okay. Now this makes sense. So this is simply 25% data. This this is just 25% quantile. This is 25 quantile, the lower boundary of box. This is the median value. This is 75 quantile. That this now you see line from here till here is calculated using what I was trying to do, IQR. This line that you see now, this line is calculated using what I was trying to do, IQR range. This is why I got confused in that. So this this is pure statistical things that why this line is like this, and this is I think calculated using Q3 minus Q2 into 1.5, something like that. So using that we calculate uh, the the value. So 1.5 times of the interquartile range. So if you see Q3 is what? Q3 is what? This is Q1, Q2, Q3, Q4. So means in 4 quarters or in 4 parts we have divided our data. 25%, 50%, 75%, and 1. Now we say this is quantile 3, 75%. So 59 minus Q1 is what? 5. This 75 minus 25. Okay, what is there at 75 quantile and what is there at 25 quantile? This minus this into 1.5. 85, 81 plus, we do it plus from 59, 140. So you see this is at 140. This is not necessary to understand. Eventually we can see this again. So I'll show you. Let's do it for another column. Okay, let's do it for votes. We're doing it for vote. Let's do it for cost. Okay, see, we have the cost column. Let's see the histogram of cost. Okay, kind is equal to histo. Now you see. Now everything we'll do again, then it would make sense. Okay, this is the histogram. Now you see there are many values between 0 to 1000, 2000, but there are very less values that are going till 8000. You know. Now you see if we do df cost cost plot kind is equal to box. Now you see what it will show. Okay, what is it saying? Okay, C is capital. Let's make it capital. Now you see this is the value. Now let's calculate all these things. Okay, let's start with first df cost, and we calculate what quantile. Okay, what all quantiles we calculate 0.25. So means this is the starting of the box. 25% of data is below this. Okay, then zero point 0.5. This is the median value. Median is what? 50% of the data is below median. Then 7, 5, and 1. Okay. Good. 1 would be the maximum value. Yeah, 75% is this. Yeah, I'll show you. 1 second. This is 25%. No, this is 25%. This one. This is 50%. This is 75%. This is interquartile range, IQR. Okay. This I'll tell you. So first you understand these three things. 0.25, 0.5, 0.75. So you see, starts from around 500. So you see, this is 500. This is around 900, green line, and this is around 1500. You see the upper box. Fine. Now, IQR is what? Q3 minus Q1 into 1.5. So this is quartile 3. This is quartile 1. This is Q2. Okay. Q1, Q2, Q3. Okay. So let's do this. What is Q3? This is 1500 minus 500 into 1.5. This is just for calculating IQR. This is a static value. Okay, this would remain same every time. And plus, so this is IQR. This I had shown you. 1 second. This I had shown is as IQR. So IQR plus your, what is this, Q3. This would give you this value. You know? So IQR is 1500, means this much data is 1500. You see, it starts from around this much and it goes to this much. So now if 1 second. Move this. Okay, this plus what is Q3? Q3 plus 1500. That is what, around 3000. So you see, this line is at 3000. Make sense? Hmm? Fine. So this is interquartile range. And what we say, anything above this range, okay, this and this blocks, these that is known as an outlier. So all these values that are in dots, these are known as outliers. So it means these are very far away from your median data or your most of the data that is present. Okay, because you see 75% data is present till here. Then even 1.5 times of this minus this, that also we have gone above till this range. So why do 1.5 times of this minus this? So this is the range of the box. Q3 minus Q1 is what? The range of the box. So into 1.5, this we consider as IQR. The 1.5 times the range of the box. So even above that, what data is there, this is known as outline. Make sense? Okay, very good. So this is known as our box plots. I've explained the box plot, plus I've also explained why we see box plot like this. Fine. Now one last plot I'll show you that is very much related to box plot, so it won't take too much time. Let's just a second. Let's see DF and let's see which column. Let's say cost only. Now we have seen bar plot, we have seen histogram, now we have seen stacked also. Then we have seen box plots also. Now we can see, I think in default pandas, this I wanted to show you violin plot actually. And I think in default pandas it is not available. Okay, so I'll just let me show you using Matplotlib. Just a second. Let's import matplotlib.pyplot as plt. Okay, and let's do plt dot plt dot violin plot. Let's see. Let's do it on cost. So this is our violin plot. Okay, but this should yeah this you saw this shows this is just like a histogram that we saw. You see, it is this the width of this shows how much data is present at this value. So this is our violin plot. So in next class, I'll show you more plots related to Matplotlib and those. And just one thing, this these are known as whiskers of the plot. This IQR range. Hmm. Put it here, whiskers, whiskers. Okay, whiskers. Whiskers are actually these cats have whiskers. These the same similarly this box plot has these whiskers. Okay. So okay then let's catch in the